Okay, welcome back to Mtale TV. My name is Robert Mtale and I'll be your pure physics tutor. Alright, so in today's topic we're going to learn the topic wave motion. Alright, so without any further ado, let's get into the topic. So the first thing we need to learn is to define what a wave is. We need to define what a wave is. So a wave is simply a disturbance in the medium that transmits energy. Alright, so once knowing the definition of the wave, we need to learn about the types of waves. We need to know the types of waves. So there are two types of waves. Namely, we have the transverse waves and the longitudinal waves. Alright, so let's start by looking at the transverse wave. So the transverse wave, by definition, is simply a wave in which the movement of particles is perpendicular to the direction of travel of the wave. One thing you need to note is that the highest point of the wave is called the crest, and the lowest point of the wave is called the trough on the graph of transverse graphs. So examples of transverse waves are water waves, light, and the wave in a wave. Alright, so that is it on transverse waves. Now we move on to the longitudinal waves. So the longitudinal wave, by definition, is simply a wave in which movement of particles is parallel to the direction of travel of the wave. Alright, so same way in the previous topic, sound. Compression simply means the area in a wave where the particles are closely together, and rarefaction is simply a region on the wave where particles are far apart. Alright, so examples of longitudinal waves. Number one, we have sound waves. Number two, we have waves on the spring. Then number three, we have seismic waves. So seismic waves are simply waves vibration in the air. Alright, so once we are done with the types of, come to the terminologies which are used in wave motion. The terms which are used in wave motions. Okay, number one, the first term we use in wave is what we call the amplitude. What is an amplitude? So an amplitude is simply, by definition, is the maximum displacement of the wave from its rest position. Then the other thing we need to know is a symbol. Amplitude is represented by the symbol capital letter A. It is always measured in meters. Then moving on to the other term, which is wavelength. So wavelength is presented by the symbol the lambda, which looks like an upside down Y. So its SI unit is also what? Meters. So by definition, wavelength is simply a distance between two successive similar points on a wave. So by definition, wavelength is the distance between two successive similar points on a wave. Alright, so that is it. Then the other term we can look at is the period. The other term is what? The period. So the period is represented by the symbol capital T, and its SI unit is what? Seconds. By definition, period is simply the time taken for one complete wave to be generated. And for formula for finding period is simply capital T is equals to 1 divided by F, where F is what? Frequency, which is our next term. So frequency is represented by symbol small letter F. SI units hertz. By definition, frequency is the number of waves generated per second. Formula for finding frequency is equals to the number of waves divided by the time taken. Alright, then the last term we need to look at under the terms in wave motion is speed. So speed is represented by the symbol capital V, and is measured in meters per second. By definition, speed of the wave is the distance traveled by the wave in 1 second. Formula for finding speed of the wave is equals to lambda times frequency. Then the other thing, the last part of the topic we need to concentrate on is what you call the change of wavelength and speed of water waves. How do they affect? So when a wave is traveling from deep water to shallow water, what happens to the wavelength? So the wavelength decreases, the speed decreases, and the frequency remains the same. But what happens if when the wave is traveling from shallow waters to deep waters? So the wavelength increases, the speed increases, and the frequency remains the same. Alright, so we are done with the wave motion the topic. Thank you for watching. I hope you have learned one or two things.